In this video, we continue our discussion of Boolean connectives. Here, the focus is not on truth tables, but rather on the notation that we use and some translation tips. We will, however, return to the truth table as a way of helping us to understand the concept of truth functional or truth table equivalence. So some of what you're about to see, you've already seen in Chapter 3. You may decide that you want to fast forward until you get to some translation tips.
Okay, so as I mentioned, we've been looking at simple sentences. That is, sentences that involve a subject and a predicate in terms of the grammatical structure. In terms of logical structure, we're talking about named entities, that is, individual constants, and what we say about them, that is, predicates. So we'll take our individual constants and our predicates and we will combine those with connectives so that we can generate more complicated sentences than we have been dealing with so far. So take a look at the sentences that are under the second bullet point. We have Flanny does not like any of the dogs. Al and Flanny are cats. Stu is in front of Al and Brett is in back of Flanny. Stu is not both in front of and in back of Flanny. It is not the case that either Flanny or Brett does not like Joe. Notice that, with the exception of the very first example, all of these sentences involve named entities and what we're saying about them. So, for example, Al is a cat, Flanny is a cat. So cat is predicated of, respectively, Al and Flanny. What we have in addition to our predicates and individual constants is a set of connectives. So look at the following words. In the first example, we have not. In the second example, we have and. In the third example, we have and. In the fourth example, we have not, and we have both and. And in the fourth example, we have not and either. Actually, two iterations of not. So if you take a look at the first example, the phrase any of the dogs is going to be phrasing that we will learn about in Chapter 9. But I wanted to include it here just to give you a flavor of the ways in which, some of the ways in which we can complicate sentences. So we've got our individual constants. As I mentioned, we've got Flanny, we've got Al, we've got Stu, Brett, and Joe. And we have, out of the atomic sentences, built compound sentences by introducing connectives. And remember, the connectives in the examples are not, and either. All right, so we already know that atomic sentences are sentences that are either true or false. In other words, they are sentences that have a truth value. We know further that in Tarski's world, the truth or falsity of a sentence is determined by whether or not expressed by the sentence obtains in a world. In other words, is there a positive correspondence between the sentence and the given world? So we'd say the sentence A is a dodeck is true if and only if there is a dodeck named A in a given world. The way that we determine truth via our Boolean connectives, that is, by our connectives negation, conjunction, and disjunction, or in ordinary language, words like not, and or, is not simply a matter of comparing the sentence with the world. Instead, what we do is we take what are called possible truth values. So a sentence, A is a dodeck, is either true or false. Those are its possible truth values. We take a sentence's possible truth values and, combined with the meaning of a given connective, we generate a value for the sentence as a whole. So, for example, if we say Flanny and Al are cats, we will find out that there are 4 possible ways for this sentence to be true or false. Flanny is a cat is either true or false. Al is a cat is either true or false. But the sentence Flanny and Al are cats is going to be true or false based on the original truth values of the atomic sentences combined with the meaning of the connective and. And I can be even a little bit more technical here. Let's say we're not talking about the meaning of the connective and so much as we're talking about what are known as the truth definitions of the connective conjunction or the word and. So what we're saying here is that there are ways in which a conjunction sentence is true or false. And those are the same regardless of the circumstances of the individual sentences. More about that in a moment. But that's why we call these truth values truth definitions for a given connective. So before we move into what it means for a sentence that is governed by a negation or a conjunction or a disjunction to be true or false, let's talk about what our new notation is going to involve. So we're going to continue using the notation we already know, right? We're going to be using a predicate, the first letter of which is capitalized, and we'll be using in parentheticals lowercase letters for individual constants. Our connectives, negation, conjunction, and disjunction, will be symbolically notated by the operators hook, caret, and wedge. So here's how we will notate our sentences using negation, conjunction, and disjunction. Let's start with negation. What negation does is deny the sentence it's negating. So the ordinary language expressions will include language like not, it is false that, it is not the case that, and so forth. You've already seen the operator. Again, I'm going to use the language operator and connective to refer synonymously both to the symbol hook, but also to the name negation. So take a look at the examples. We have the hook in front of every sentence that's negated. It's not going to be the case that the hook comes behind or on the right side of the sentence that's negated. It always appears in front of or on the left side of the sentence that's negated. We can articulate the negation of an identity statement either, as you see in the example, the third example, it's not the case parenthetical, Al is identical with Flanny, close parenthetical. We also have in our notation toolbox the identity symbol with a cross through it. That slash tells us that it's not the case that X and Y are identical. The second of our third connectives is conjunction. Conjunction affirms the conjoining of two sentences. Typically, we see in ordinary language conjunction expressed by the words and, both, yet, still, moreover, nevertheless, and so forth. So when we have a conjunction sentence, we have a sentence that says X and Y are true, or we have a sentence that says both X and Y. Take a look at the examples below, and you'll see that the connective conjunction always appears between sentences, right? So it's not like the negation, which is always to the left of whatever sentence it negates. In other words, it's always out front, right? Conjunction is always sandwiched in between sentences. Lastly, let's look at the connective disjunction. The disjunction is the connective that expresses a disjunctive relationship between two sentences. Our ordinary language expressions for disjunction include or, either or, otherwise, and so forth. Now, there's going to be something a little bit apparently tricky about the or, but once you grasp what that apparent trickiness is, you'll see that, in fact, it's only apparent and it won't prevent you from understanding what's going on. But first, let's look at how this operator works in the notation. Like the conjunction, the disjunction is always sandwiched between sentences. The disjunction is never out in front of or behind a sentence or set of sentences. So you need two or more sentences if you're going to have a disjunction. Now we get to the apparent confusion about disjunction. If you think about how we ordinarily consider or use or, we typically think of it as exclusive. You can have soup or salad. The implication, not stated, is but not both. But logic doesn't know from unstated implications, right? Instead, if you mean an exclusive or, you're going to have to assert it. Otherwise, the or is inclusive. I hope once we see a couple of examples, this will make some sense. So here's an example. If I have the sentence, Flanny or Shazi is black, that sentence is true provided at least one of those cats is black. So my cat Flanny is black. That sentence is true. We would say very comfortably that since the sentence Flanny is black is true, the sentence Flanny or Shazi is black is true. All we need to know is that at least one of the disjuncts is true for the disjunction as a whole to be true. It could be the case that both Flanny and Shazi are black, and in fact, that is the case. I have a cat named Flanny, and she is black. Therefore, the sentence Flanny or Shazi is black is true. Turns out, my cat Shazi is also black. But that doesn't change the truth of the disjunction. Let's see how this plays out in the truth table.
Okay, so here are just a few translation tips for you to bear in mind as you work through translating ordinary language sentences into symbolic logic notation. First, the negation always appears to the left of whatever sentence it negates. So in the example that I provided you, Lois believes in a free press, but Charles doesn't, just because the negation in the ordinary language sentence appears at the end of that sentence, that does not mean that you tack the negation symbol, the hook, on at the end of your translation. Rather, that hook or the negation symbol goes immediately before the C. It precedes immediately the capital letter C in the notated sentence L conjunction negation C. Secondly, both the conjunction and disjunction symbols are sandwiched between sentences. So they are like the joints or the hinges or the stuff inside the bread when you're dealing with sentences where the conjunction or the disjunction is the main connective. Take a look at these two examples. Ahmet or Boyd is staying home to study. Is A disjunction B not disjunction AB, for example? The disjunction doesn't appear outside of, if you will, the sentences that it connects. Similarly, Harper and Rolf are at the library is translated as H conjunction R, not, for example, HR conjunction. Lastly, An ordinary language sentence beginning with a connective is almost invariably translated with that connective as the main operator. Take a look at the examples. Not both Kyle and Deshawn are working late. The first the first word of the ordinary language sentence is the negation. That's what drives the sentence. The negation rejects or negates the conjunction. Hence, the conjunction is in a pair of parentheses and the negation's out front. On the other hand, both Alejandra and Keisha are not anime fans starts with the word both, which is a conjunction word. That means that the conjunction is the main connective, and the negation for Alejandra and Keisha appear on either side of that conjunction. Lastly, either Julio or Brandon can work the register is translated with the disjunction because the disjunction because the connective disjunction appears at the outset of the sentence that begins either. Now, if you don't have a connective that begins the sentence in the ordinary language version, that doesn't mean that you don't have a way to translate. We already know this. But just as a reminder, it's not always the case that when your sentence begins with, in ordinary language, a connective, that connective is the main operator or main connective. Let me give you an example. Let's look at the first example. Either Julio or Brandon can work the register, but Alex can't. The flow of the sentence, along with the punctuation, tell us that the first clause, Julio or Brandon can work the register, goes on the left side of a conjunction. That conjunction is expressed by the ordinary language word but. And then we're told that it's not the case that Alex can work the register. So here, although the English language word either, as part of the phrase either or, appears at the start of the sentence, that doesn't make the disjunction the main connective. In fact, it's the conjunction that connects the J disjunction B with the negation A. Similarly, look at the second example. Neither Trish nor Fatima are in the library, and Phil or Willard is in the cafeteria. The negation does govern the disjunction that's on the left side of the conjunction, in the middle, which is sandwiched in the middle of the two parentheticals. So the negation covers part of the sentence, but it does not govern the whole. The sentence that is not in parentheses, with very few exceptions, is the sentence that governs the whole. Here we have two connectives that are outside of parentheses. We've got the negation, we've got the conjunction. But, as I mentioned a moment ago, the scope of the negation is limited to the disjunction in that first parenthetical. On the other hand, the conjunction, also free from parentheticals, is what unites both of its sides, the left and the right. Let's take a little bit of time now to focus on the role of parentheses in our symbolic logic notation. Parentheses, like commas, disambiguate sentences. They also specify the scope of a connective. So let's start with disambiguation. Look at the three sentences under that first bullet point. The first sentence, the first iteration of the same sentence, does not have any punctuation besides the period, so we don't know which is the main connective. Is it the disjunction or the conjunction? Notice that in the second and the third examples, the comma helps us to see that, respectively, the disjunction is the main connective, and the third, that is, the second iteration of the comma, which appears in the third sentence, tells us that the conjunction is the main connective. So a related topic then is how parentheses specify the scope of a connective. Take a look at the three examples. Parentheses tell us that each of the disjunctions within their respective parenthetical acts as a unit, so that the sentence A disjunction B and the sentence C disjunction B are treated as a unit. So the sentence as a whole is left side of the conjunction, conjunction, right side of the conjunction, where the left and the right side of the conjunction happen to be disjunctive sentences. Take a look at the second example. There's no parentheses here, so that tells us that the negation scope is limited to A. On the other hand, the negation in front of a parenthetical tells us that that negation's scope covers the entire sentence, or another way to put this is that the negation rejects the conjunction within the parenthetical.
Now that we know that negation, conjunction, and disjunction are each connectives whose truth definitions are functions of the atomic sentences and the meaning of the respective connective in each sentence, we can start to see how sentences could be equivalent to each other. One of the things that we'll want to do is learn how to use Boole to construct a truth table. But right now, let's just focus on the following. Let's focus on what it is that we're saying when we say that sentences are tautologically, aka truth functionally, equivalent to each other. So we'll get into what it means to build a truth table in a little bit. Okay, so what I'm going to do is I'm going to take us to Boole, and I'll take us to Boole where you will see that I have already laid out the atomic sentences for the double negation equivalence and the two De Morgan's equivalences. And then what I'd like us to do, like I said a moment ago, is to focus on understanding how it is that the sentences in question are truth functionally equivalent.
In our ordinary language, it's easy to think of certain sentences as equivalent when, in fact, logically, they're not. Here's a fairly common example, at least structurally. Not both Reggie and Felicia are in the library. In other words, one of them is in the library. No, that's actually not the case. In other words, to say not both Reggie and Felicia are in the library is not equivalent to saying one or the other is in the library. We need to make sure that the negation is preserved when we draw the equivalent sentence. So the sentence negation parenthesis R conjunction F closed parenthesis is not equivalent to R disjunction F. We preserve the negation instead, which reveals in ordinary language that we do not know which one is not in the library. In other words, not both Reggie and Felicia are in the library, truth functionally equivalent to saying either it's not the case that Reggie is in the library or it's not the case that Felicia is in the library. I hope this focus on notation and translation has been helpful to you.